Hi there. Thanks for tuning in for what will hopefully be the last of the video lectures for SWE 432 this fall 2018. I apologize once again for my absence, although I guess this one was planned. As I think I mentioned, I'll be at this conference in Boston, and on Tuesday, yesterday, organized a pretty cool undergraduate mentoring workshop for students who are interested in research. So if you're interested in computer science research, I'd encourage you to check out this series of mentoring workshops, PLMW. Today we're going to talk about design thinking and conceptual design. So this is going to start bringing us towards actually sketching things out, and in the next few lectures building prototypes, at least on paper. Well, we'll see what conceptual design is in a moment. As a review from Monday, on Monday we talked about usability, and how usability was a lot more than just dummy proofing or being user-friendly or just testing things or making things look pretty, but usability really encompassed all of these different factors that came together to make software usable, for lack of a better term. And how one way to try to evaluate that something is usable and make things more usable was using the set of 10 usability heuristics, like being able to see what's happening in a system and preventing errors and encouraging flexibility. We talked about how you could use those different heuristics to evaluate a piece of software in terms of its usability, and rather than just say something is usable or not, come closer to having concrete suggestions for improvements. Like if we were to take a look at this interface here for downloading files using this wget GUI, you might immediately look at it and just kind of cringe and say, I don't really understand how to use that. But how can we start to refine that and say, here are specific issues that could be improved? And we said, looking at this, that maybe one of them is, for sure, we're not following this aesthetic and minimalist design. We've got lots of options. The options are good because it gives the user control, but the options are bad because the way that they're laid out doesn't really follow things. Things like saying these categories here are like special. I have no idea what the difference between an option under special was and running options is. We talked about applying this kind of heuristic evaluation to lots of different interfaces. So to get started thinking about what I mean by these kinds of design concepts, let's look at 4 completely different designs that solve the same problem, which is going to be looking at files on my computer. So I'm showing here 4 different screenshots showing the same folder on my Mac. You can see the first one on the top left, we show a list of files, and it seems like folders are kind of show this nesting thing that I've got this drop down that's maybe this affordance that says I can look into this folder and browse it and see inside of it. And then otherwise we've got small icons for these things. We can probably sort them by name or by when they were created. I've got this other design here which shows all of the files in these columns. So when I open a folder, it's going to be nested like this and show the folder over there. I've got this third option down here in the bottom left where I show these big icons, and when I click on one of those icons, I see a preview of that file in the middle here. And then I've got finally this last view here, which is maybe the default in the Mac, where all of the files show up. You can kind of see this larger size icon, larger compared to this case and this case, and then you have the name under it, and these things can get dragged around. Versus here, they're not getting dragged around, they're in a list. So these are 4 completely different ways of viewing files on your computer. And you got to kind of think to yourself, how did we get here? There's a lot of different design that happens here, right? There's the design that we have where someone said, well, this color is going to be blue and the folder is going to look like that, and that's what that icon is going to look like. And we'll talk all about icons later in another class. But like at a high level, someone sat down and said, well, we could have this list. I'll show files as a list and you can sort the list, or I'll show files as these nested lists with these columns that you have one list here and then you can have another list here. or I'll show files with these big icons, and then one of them where you can drag the icons around, and this one you can't drag these around, but you can click between them and see a preview of it. And we need to have some process whereby we come up with these different designs, and before we start implementing them or thinking about these design details again, like what the icons look like or what the colors look like, just these high-level things where I said I've got the list or I've got the icons I can drag around. Why would I want to pick one over the other? Why would I want to implement one over the other? Why would I want to allow the user to switch between them? So when we start out with the problem here, which is browsing files on our computer, if we wanted to start designing something, we might start off with sketching. So sketching really helps us in design because as we're designing something like this, we're trying to create something new, but more importantly, we're trying to explore different options. And sketching is going to give us this visual medium. We're going to put things down onto paper that's going to allow us to explore more. So we can think about designs in our head as much as we like, but it's difficult to actually completely understand what the implications might be, what the pros and cons might be over one design over another until we get things down on paper. So this cognitive scaffolding is like taking the thoughts in our brain, that cognition, and using some external thing like paper to help remember those things and visualize them. And sketches allow us to explore many alternative designs cheaply. So why do we want to consider different alternatives? It's really important to think about broadly all of the possible different designs that we might want to implement. So what are the different ways in which a user might do X? What are the different ways in which a user might look at files? Well, they might look at files and have them listed alphabetically. All right, we've got a list option. They might have files and have them structured hierarchically. Like you have folders and folders and folders, and that structure is important to us. Or maybe what's important is looking at a few files and seeing some visualization of what's inside of them. Or maybe what was important was giving the user the affordance to drag files around. And those are at least 4 alternatives here, right, for how we're going to interact with our files and view them and find them. And there are certainly other alternatives that we can think of too, right? And we'll get to at least one of those alternatives later as our case study today. So when we're trying to actually design something, if it's important enough that we think about it as a design problem, it's probably important that rather than just re-implementing the status quo and doing things how they've always been done, considering alternatives might be helpful to come up with maybe better ways of doing things differently. And once we come up with these alternatives, we can try to answer questions and analyze what about them is good and what about them is bad, and choose which design is going to be the best for our specific use case. This is going to let us challenge preconceptions and think more deeply. These are 4 different ways of viewing files on a Mac. And when things started off, there were only 2 different ways, right? Which was the top left option here, where you're viewing files in a list, and the bottom right one here, where you're viewing files and you can kind of drag their icons around in whatever way you want. This option with the columns and this option with the previews is relatively new as far as computer interaction goes. This one, certainly the column browser, I think maybe the first Mac OS X had this, but it definitely in the past 10 years, and this kind of visualization is probably in the past 5 years. In comparison, like this is the way that we've been looking at files since at least the 80s, the same here too. So we can come up with all of these different alternatives. Maybe one of them is going to be good. Expert designers often create lots of different alternatives and go through them. So why we like sketching is going to let us develop some idea and explore it and consider different designs and look at the pros and cons of them. So what do we mean exactly by sketching? So sometimes there's confusion maybe between what sketching is and what prototyping is. We're going to talk about prototyping next week, but today we're going to be talking about sketching. So sketching is really something that we do for design, whereas prototyping is something that we do for user interaction engineering. So UX engineering, again, we'll talk about next week, but this is maybe more considering the details, whereas sketching, we're considering these high-level designs, like am I organizing stuff in a list or am I organizing stuff in columns? Designing maybe is for getting the right design, so picking between those alternatives, rather than getting the details of that design right. So those details were maybe what exactly the icons looked like, or what the colors we picked were, or the relative sizing of the different components, but we're really just in this sketching phase, in this design phase, trying to pick this right high-level design. Sketches are good for experimenting, for exploring, for being creative, for coming up with completely new, or at least new to that application, options for how we do an interaction. And ultimately, the goal of our sketching should be to support us as designers to finding the great design solution. And after we found that great design solution, we can move on to prototyping and really refine that design. That's what we'll talk about next week. So for building physical sketches, there are lots of different kinds of tools that you could use. Oftentimes, there's software that does this too, but frankly, sometimes just doing things by hand can be the easiest, using things like whiteboards or blackboards, flip charts, Post-it notes, tape, pens, getting really intense using things like scissors and duct tape can be useful so that you can take parts of a design and move them around physically, like doing copy-paste. I don't know if I'm dating myself here, but I used to copy and paste things by taking a textbook and putting it in the copier and pasting it somewhere else and then recopying it. Copy-paste, haha. But you can use all different kinds of physical materials for sketching. And when we do sketching, we really want them to be freehand kinds of gestures, open gestures, rather than mechanically correct and perfectly straight lines. Doing things that are straight and look more refined, you really don't want to have while you're sketching, because by nature, we want to leave things open, right? We want to have low resolution, low detail to just suggest the concept here. If I were to start sketching out how we're going to be looking at our files, we probably don't want me to be putting color in there, because then you might say, did you pick the right color? Or even putting kinds of icons in there, or showing that one item is much bigger than another item. Unless that's a distinction that's really important, we want to leave this stuff kind of ambiguous and abstract, leaving holes that our imagination can fill in. So we can look at these designs, these high-level designs, and say, I see how these pieces work together, and I see how I could use this, but we don't want to have our designs and our sketches at this point judged based on their details. Just are thinking about concepts. Sketching is nice because it involves no programming, although that's also the case for prototyping, which we'll see next week. But even compared to prototyping, you can have a much faster turnaround when you're doing sketching, might cost less, and really importantly, we can have more iterations. So you can sit down and maybe come up with a few dozen sketches in an hour, whereas building prototypes, maybe you could come up with a prototype in a few hours. Whereas building your actual system that you're building, maybe you could build your system in a few months. So this is really this earliest period in our design where we're going to just be brainstorming and coming up with different kinds of ideas. Sketching is nice, similar for paper prototyping. Again, we'll talk about next week. Because we're not going to do this on a computer, we'll just do it ourselves, humans, which means that we can program and reprogram it quickly. If we have some notion for how something should be interacted with and that notion changes, that's fine. We will just do it differently. But we're not at the point yet where things have been coded up and when we're stuck and I say, oh man, but I've already built these React components and now the components are going to have to get nested differently and the properties are, nope, right? We just are going to redo that all ourselves in our head, make these changes on the fly. We're not going to run into errors or crashes because it's just us doing it. When you're building these sketches, because we have less vested in each sketch, usually it makes it a little bit easier to come up with designs that push the status quo more because it's really easy to change them at this point. If we start off even doing this is kind of why I don't like doing sketching in a computer-aided tool. If you use a computer-aided tool, you're still going to kind of be stuck to whatever kinds of options the tool gives you. But if you're doing sketching by hand, it's going to be a lot easier to just pick up a different color pen or cut a piece of paper, put a transparency over something to make these changes quick. Again, we do this rough, sketchy appearance, which is going to emphasize the content of our design instead of the appearance. At this point, we should not have people critiquing our designs at this low level on the visual detail because there will not be visual detail. And instead, we're going to think about these high-level problems that might occur between different designs because we're not looking at the details. So for instance, maybe in this case here, we would like to draw out some sketches for two different ways to look at files. And I did that. I made these super simple sketches using paper and a pencil. You can tell that really nothing is straight here, which is fine because it leaves it up to your imagination of maybe the file icon should have straight edges or rounded edges. You can fill that in. But you can definitely tell between these two different sketches. I've got this list version of looking at files. I've got this icon version of looking at files. That there are going to be differences between these, right, and how we can use them. In the list version, you can tell that this is going to look like a table. And you can kind of see that I've got this little icon there next to each file, and maybe I have the name of the file. And I purposely left the right side of the table there empty, and you can envision that maybe there's just a scroll bar there, maybe there are more columns there, I don't really know. What's important when we're comparing these two different sketches is not those details, but what's important is these high-level differences. One of them is a table and it's a list, and when we have tables, usually we can't arbitrarily reorder items. I can sort them by what the column headers are, but I can't drag and drop them to move them. On the right side, I've got this icon-based version where I just have a whole bunch of different icons and the name of the file under them. Maybe they're arranged kind of in a grid, maybe they're not. They kind of look like they are, but they also kind of look like they're not. And it's unclear if that's due to whether I drew it poorly or because of my intentions. And the answer is my intentions were kind of vague. But if we were to consider these two design options, we see the left one, maybe we can't drag things around. On the right one, we're used to dragging icons around. That's kind of a convention that we've got. So I can probably reorder things as much as I want. Another detail that maybe is important that we can tell is on the left side the icons are small and on the right side the icons are bigger. The one file has this kind of person drawn in their little icon, and you can see that a little bit better on the right one than on the left one. But drawing these high-level sketches, I think that it should be clear what I mean in terms of these things being quick and being easy. So what are the rules for sketching? Everyone can sketch. You definitely do not need to be artistic in any way to do sketches. You can tell from that example, you don't even have to have good handwriting necessarily to do it. Most of the ideas are being conveyed more effectively with a sketch than with words, right? I could try to describe to you this notion right now of having these different ways to look at files, maybe in a list or as icons, but it's not really clear what I mean. If I flip back to this, though, it's immediately in your head and you can recognize this, right? in terms of what the differences are between them. Sketches are quick and inexpensive to create. I drew those in like 1 second. And don't inhibit early exploration. So we can just pull up lots of these ideas out of thin air and try them and see what happens. Doesn't really matter, right? There's not much investment in the sketch itself. This is just something I jotted down in pencil on paper, and if I threw it away, that wouldn't be a huge problem. Sketches are timely. We make them just in the moment. You come up with an idea and you draw them, and we make lots of them. We can fit lots of different ideas into a single sketch by adding annotations. So here's an example of a maybe slightly better sketch that I didn't draw, taken from this book, where you can see that we are drawing some sketch. It says revisiting this project. We're showing these different views. You can see that there's text. It's important, I guess, that the cursor area fades in. If the cursor moves above the line, up, change the display units from Celsius to Kelvin, and if it moves down, it changes. We have these annotations basically describing how the sketch works. We can use a sketchbook. We can explore a design space by coming up with little ideas, small sketches that explain some part of a system, which then might bring on more questions like how different pieces are going to interact with each other. In terms of fidelity, we have certainly a range in terms of sketches that are very low fidelity with many details left unspecified, and high fidelity, being more polished and detailed. So again, today we're focusing on the left side of the spectrum here, the storyboarding kind of sketches, the lowest fidelity, and we'll maybe push a little bit into wireframing, and we'll revisit prototyping on Monday. But you can see these high-level differences, that the storyboard looks very sketchy. It kind of shows what a user might be doing, coming up with this idea to interact with an app and then doing it. The wireframe is showing a little bit more of a design in terms of what the different affordances are that a user can interact with. And the prototype has a lot more details in it. We can see that there are tabs in this interface, and we can see that they're rounded tabs, and we can see that there are buttons, and we can see where all of those things are laid out together. So here's a different example for sketching that maybe is a little bit more complicated than just doing the file browser, which would be building an application that lets users view news items like a newsreader, RSS screen reader. So here you can see a sketch that's been given this title called Dada, or drag and drop articles. And this sketch represents some design where a user can see lots of different news articles, and you can see we've got this annotation here saying that this is an article layout where we've got these movable windows. There are some notes at the bottom that say we've got movable windows. Maybe these windows are layered by importance, so this is maybe a more important news story than this one. We can see that the articles, I guess, have a close button, which is important, but it's important that there's a close button, but it's not important exactly what it looks like. So you can tell this X means close probably, but maybe it's a red button, maybe it's here, maybe it's here, maybe it's here, maybe it says close, maybe it's a circle, I don't know. And I guess that we're not just showing headlines, we're also showing the images, if there are images too. You could consider this this kind of sketch in terms of how usable it might be. Maybe there's too much going on here though, right? Showing a lot of news articles at once to a user might be really confusing, right? Like if you actually thought this one out and saw that there were text in this, there would just be all these different pages on the screen. It's like having a desk that has a million papers laid out all over it. It can be a little bit confusing and difficult to go through and maybe gives some information overload. So maybe you could build a different kind of sketch where instead you want to convey how news occurs over time. So this time we could show a timeline. You can tell that it's annotated with different days, and you can see that there are some small representations of each story that maybe they're important stories that are tied to a day. You could see maybe how someone could explain to you that this design is an evolution of this design. First someone said it was a good idea to show lots of different articles, and here's one way to do it. And this is going to give a lot more organization to that. We still have these common concepts that we've got the news items being shown in these boxes, but maybe they're smaller now, maybe I'm showing less of them. It looks like there's some stacking thing that's happening. It looks like there's some stacking thing that's happening in here, right, where I've got multiple articles that are showing up on top of each other, maybe because they're very related. I'm not sure why exactly they stack, but that's maybe a detail that could be decided later. It's just what's important here is that this lets you stack them. You could consider this design and say, well, maybe this solves that problem of things were too confusing on the past one because I just had all of these news articles laid out in front of me. Now they're sorted by date, so maybe that's better, but maybe it's still cluttered. So we still have that problem. If you're looking at a big time frame with many articles, like this is a week, I guess, or 4 days. If it were bigger, this would probably start to be really crazy, so maybe you don't want to take this kind of design further. But maybe there was stuff that was good from it too. Then maybe you could build another design like this, where you could show, I guess this isn't even sketcher design. I guess the importance here is just that we're showing an evolution here, right? What is important in this design compared to this design? Well, what's important is the articles are still being showing many of them at once. Maybe they're just going to show up in these boxes here, or maybe in different size boxes. It's important that we have tabs that show the articles organized by some sort of category. Then we have these different size boxes with simple format. Maybe a bigger box means that an article is more important, and then it'll be easier to tell which ones are more important and you could see them. You could do color coding. You could have all these annotations describing it. So what we've got here are these 3 different designs that all accomplish that same goal of displaying multiple news articles to a user at once. We didn't really invest much in actually building these sketches, right? Like someone had this idea and said, let's just throw a bunch of articles on the screen in different windows. All right, let's see what that looks like, and then you got it. Once we have that, we can recognize things that are maybe good and bad about it. It's good we can see multiple things. It's bad that it's maybe information overload. You can say, oh, maybe we should try organizing that. So, oh, we could organize them by time because news occurs at time, always. Build a timeline and see what that looks like. See what's good, see what's bad, and then maybe come up with a different idea too, which is organize things by importance and category. Sketching allowed us to come up with different designs quickly, and it's not really a formal evaluation here, right? It's just understanding maybe high-level pros and cons of those designs. So this is doing conceptual design. We're coming up with these designs, thinking about the kinds of concepts that we're presenting and how users might interact with them. So when we're doing these, let's return quickly to this notion of mental model. You might remember we were talking about this term in terms of the human cognition stuff, where we were talking about how we build these refrigerators and freezers that have this weird thing going on where they have a single cooling unit, so therefore the temperature is going to be changing in both the freezer and the refrigerator at once. So the mental model is how we have this conceptualization of this system. What the system is, how it's organized, what it does, and how it works. And the person who designed the refrigerator or freezer unit probably had this, probably had this mental model, right? I'm building the thing, it's cheaper, cooling units are expensive, I'm going to put only one cooling unit in with a valve, and that's my model of how that thing works. We said maybe there was a problem here because the user has their own mental model, which instead of coming from building the system, comes from how they interact with the systems. And the user forms cause and effect relationships, maybe based on theories guiding these actions. So I have this theory that making one colder is independent from making the other colder. The user probably has this kind of mental model about their refrigerator or freezer, that there is one cooling unit for the freezer and one for the fridge, so turning these things are independent. Whereas we've got this mismatch that the designer built it like this. So the goal in conceptual design is to match the user's mental model. So we are designers, we are building things, we're working with engineers who are building things, or maybe we're those engineers too. And in doing so, we need to try to anticipate and understand how the user will see something. Oftentimes, what we use here are metaphors taken from an existing system, which can offer some expectations to the user about what the system does and what can be done. So for instance, there's an easy kind of metaphor between email and physical mail, right? I can take a letter and I can send it and I can receive letters, and maybe I have an inbox. I might have different folders that I file my mail into. Mail comes from an entity. It can only come from one person. I can send mail to multiple people. I can send copies of mail to other people. This is matching the user's mental model. And that mental model was built up by their interactions with the world, for instance, sending mail. Similarly, examples, you think about backup software, comparing that to a time machine, which is in fact exactly what Apple did with their backup software called Time Machine. What is backup software? Well, it's something that saves your files, and by the way, there's this complicated way where it does this differencing algorithm to tell which files need to be saved so it doesn't save too many files. That's all very complicated, right? And that doesn't necessarily match what the user wants. What the user wants is a time machine that they can push and say, go back in time, let me see those old files again. So mapping users' mental models. So we looked at the concept of this sketching in just looking at those individual frames. I looked at those 3 different designs. It's also worth talking briefly about storyboards. Storyboards show different frames of a scene over time. You can build storyboards for any kind of interaction. You can build storyboards for, most easily in this example, television, taken here from a Disney short. And the storyboard displays some part of a scene that's important, maybe some annotations that describe what's going on in that scene. So here you have some pretty well drawn out scene that's showing a lot of detail, probably the level of detail that the eventual animation was going to have, along with some dialogue. So we can build storyboards for user interaction design too. So in user interaction design, when we build storyboards, we have these frames that are going to illustrate the interplay between the user and the system that we're building. So I can build a single sketch, and that single sketch is just going to show some view of the system, but it doesn't show how the user interacts with the system. So that's where storyboarding is going to come in. Storyboarding explains how this app fits into maybe a larger context through this scenario. So storyboards bring design to life, perhaps in graphical clips. You could build freeze frame sketches of user interactions. So we'll have not just a single sketch, but multiple sketches showing along the line how things go. We could also build comic book style illustrations of a scenario actually including, for instance, the user in it. how we build storyboards. Start out by setting the stage, the who, what, why, when, where. We show key interaction with the application and importantly, consequences of taking actions and maybe errors. What goes in our storyboards? We have hand-sketched pictures, just like the sketches maybe that we're building otherwise, with a few words drawn on them perhaps. We show a sketch of what the system looks like from the user's perspective before and after interacting with the system, and then also of the different devices and screens as we're going through the system. We might show connections within the system, getting down to be more technical in terms of the implementation, maybe even physical user interactions. And we can try and capture perhaps part of these the user mental models with thought balloons, literal thought balloons, like we were drawing a comic book to try to indicate what the user is thinking. So for instance, if we look back at the storyboard, we see how the user is progressing, right? That the user is going to enter their PIN, which is going to enable the transition to this frame where recommendations are being shown for that user. If we're drawing this whole thing out in a storyboard, though, we might want to consider here other possible transitions too, right? Like, what happens if invalid? Or what happens in this frame if the user decides that they want something that's not a recommendation or not a popular category? Is there some sort of search? After the buyer selects something, are there more complications here that might show up? Like if I'm buying tickets to the symphony, well, not sure what complications there are here. There's certainly complications that might show up here, though. If you're picking a date and time for that symphony, maybe you also need to pick seats, or maybe you want to enable more features here, like upselling a user to also be like, hey, do you want to pre-purchase dinner at a nearby restaurant or something like this too? It's unclear what happens as we go through this process if the user makes a mistake and wants to go back. So maybe in this bottom left frame here where the buyer is selecting a symphony, what happens clearly, like the transition here was select concert. But what happens now if the user wants to unselect concert? It makes it a lot easier to reason through what the kinds of error cases are that are maybe not flowing through the normal kind of scenario when we set out and draw these storyboards. So there are many different problems that can be occurring as we go through these actions. Those were those gulfs of execution and evaluation, right? Where the user has some overall goal in mind that they'd like to achieve, and they're trying to figure out how to achieve that goal using our interface. It can be useful to think about how these interactions work and how things step between them. Again, maybe adding thought bubbles here is useful to make clear what the user is thinking and how that maps onto the interaction. Oops, I keep doing that, and now it's gone. But in this case, maybe the user has some thought, which is, oh, music sounds good. And then it's kind of clear why the user is going to go down and select a symphony or a concert. But if instead the thought that the user has down here is, oh, no good music today, then it kind of makes clear that the user is going to be stuck if this is the only kind of transition that they can make, which is selecting a symphony, that they need some way to go back and select something else. So here's an example of a design fail where maybe storyboarding would have helped. And what's really frustrating and unfortunate with this example is I took these screenshots since 2016 when I last taught this class, and Yesterday, as I was walking out of the airplane, had the exact same thing happen with Piazza, and they still haven't fixed this. So if you open Piazza on your phone, and it's not already open, like running in the background, you'll get this automatic login if you've saved your email and password, which probably you have on Piazza because, well, why wouldn't you? And it's going to just automatically log you in, which is great, and that's normally what you see. But if your phone isn't actually connected to the internet for some reason, like if you're on some stupid Wi-Fi network that wants you to log in, or if you're in an area where you have cell bars but no actual reception, you'll get this screen that will say that there's a network error. Please try again later with logging in. And then you click the X, and now you're back at this screen that asks for your password and won't automatically log you in. And this was super frustrating when I took these screenshots because that was before the iOS password manager would automatically fill in your password. And instead, I'd have to either type in my password or open my other password manager and copy and paste the password in, and that's a huge pain in the butt. And this is just because when the designers of Piazza thought through what the transitions might be, they clearly thought through what happens if you're on this login page and you have an error you get here, which will bring you back effectively to the same state. But what's not well thought out here is if you're starting out in this state, which is I am being logged in automatically, you should be okay to show just this part of the error. But then after you tap to dismiss, we want it to go back to this state where it's like, oh yes, I do know your password and I can automatically log you in. All right. So I'd like to zoom out now, and we've talked about sketching as a way to get our designs onto paper, and we've talked about storyboarding as a way to put those sketches together and see how a user will work through an interaction. But let's step back and talk about where we start. So I'd like to start sketching something to start designing something, but how do I start thinking in the right mindset and trying to understand what it is that I need to build? So we might do a process called need finding, or generally design research. And the goal of need finding, as you might guess from the name, is to understand what the user's needs are. So this is a key part of user-centered design. We would like to design something that is built specifically for our users, so let's understand what it is that our users need. We use different kinds of methods to gather qualitative data. So qualitative data as opposed to quantitative data is going to be describing things like behaviors and attitudes, what it is that our users want, what their aptitudes are, so how skilled are they at interacting with these kinds of systems and performing these kinds of tasks. Do I have users who already do some tasks manually on paper a lot and are really good at it, and now I need to build some sort of digital interface for them? Or instead, do I have users who don't know how to do any part of this task and they're new to this entire system, this entire way of doing things, and I'm building something for them? We also need to learn about the technical, business, and environmental context. This is the domain. If I'm building an interface for stock traders on the New York Stock Exchange, we'll probably have different domain requirements than if I was building an interface for nurses in a hospital or building an interface for all of you students working with a system like Blackboard. There are just different requirements that come from those domains. Those domains were like finance and health and education. They're just kind of different expectations and different ways that things are done. And a lot of that comes down to things like having specific vocabulary and social aspects. Things that already come from how nurses refer to patients and operations and the health and status of patients. We can have maybe a very technical language and jargon. And similarly, if you have traders who have an axe out, that's traders who are trying to buy or sell something, but that's kind of weird to talk about this term of axes in other cases. Doing this need finding really empowers the design team with credibility and authority, lets them understand more what the users are thinking and want, and then gives them a lot more credibility when you come up with some design and you go back to your users, and hopefully they're going to say, oh, this is interesting, you're doing something that I asked for or that meets my needs. rather than just doing nothing. That helps. So how do we conduct studies like this? There are two high-level approaches: interviews and observational studies. So for interviews, we take users and we ask them questions. We might include both current users, users who are using our product or a product like ours, or users who are doing a task that needs to be done now, even if there's no like interface that seems like it's been particularly designed for that problem. If we were talking about the example from the beginning of this lecture where we're talking about how we file information on the computer, maybe you're interested in looking at users who file lots of information already on the computer, but you might also just generally be interested in users who file information broadly with the computer or not. Those would be maybe potential users of your system that have very related needs. And you could ask them lots of questions like how the product that you'd like to design fits into their lives or work, when, why, or how the product is going to be used more broadly without leading with the thing that you're trying to design. You can ask simply what do you need to know in order to do your job? And what are the tasks and activities that you're trying to do, either that are or not supported? So if we were asking these questions about filing data on the computer, you could say, well, how is it that you file data currently, and how do you wish that you could do that? And what are the when you're looking for data, how do you do that, and what is it that you're looking for instance? You could also ask broad questions. If there are comparable systems, you could ask about those. Interviews can be useful, but kind of the issue with them overall is that we as humans often have problems accurately assessing our own behaviors. So if I were to ask how it is that you file information on the computer right now, you might come up with some answer that doesn't necessarily reflect exactly how you do it. One reason might be that you don't really want to talk about problems that you have doing this task because you might feel dumb, or you might just do stuff by second nature and not really even think hard about what it is that you're doing or how you're doing it, and not be able to then effectively say what it is that you do. So observational studies often yield much more accurate data if possible. In an observational study, we simply observe a user doing a task. So if our task was filing information on the computer, we could ask for their consent to simply observe how they file information on the computer and capture different kinds of behaviors, taking notes, taking photos of what they do, if possible, doing video recording of it. So from these studies, we can start doing contextual design. So contextual design is this approach to answering the question, what is it that we need to build to help people do their work better? Starting really from the ground up. So we can perform inquiry, we can gather data from customers while they do their work, do these observational studies to decide what our system should do. After we do that kind of inquiry and do these studies, we can use that data to build models about what it is that users do and how that work happens. Maybe we'll build these sketches and we'll start storyboarding. We'll look at what it is that users do now and then try to redesign that. So using the data that we've got, using the models, maybe storyboards that we've built out of how it is that our customers are performing these tasks, we can try to redesign that then. And then do this iterative process where we're going to repeat this design based on how it is that the users are using things right now. So let's talk about a case study now in design thinking and in sketching and in storyboarding a little bit. So this case study comes on an actual case study performed at Apple Computer in 1992. So this was quite some years ago. But it's a really fun study because it still is very relevant today. So context is we're at Apple, it's 1992, so this is like just after the Macintosh is starting to become, a product. GUIs are like doing really good. We're Microsoft, we're at Windows 3.1. Windows systems are, taking off. Wow, Windows, that's going to be popular one day, I bet. There are 3 researchers inside of Apple's user interaction department who are trying to solve this design problem broadly of how computers should help users organize and file information. So at this time, computers are becoming popular in businesses, but they're nowhere near as popular as they are today. And still a lot of data that workers are handling is on paper. So if I'm receiving mail, I'm not receiving email, I'm receiving paper, right? If I'm getting a copy of a report that you generated, I'm getting a physical paper copy of the report that you generated. And then when I get that thing, I am storing it physically in my office somewhere. And Apple really wants to be on the forefront of this, to have some product that all of these office workers are going to find to be really useful and productive, and maybe more useful and more productive than a competitor system, and then continue to adopt the Macintosh system. So the question is, how should computers help all of these users who are getting lots of information left and right store, organize, file, and retrieve that information? So their method was to try to study how users organize and file information without computers. So what they're looking for are maybe power users, but not power users of computers. We're looking for power users who receive lots of information and process all of that information without seeing a computer. And we'll see, well, how can we take your best practices and bring that into a computer? Maybe part of the motivation here was a quote from the paper that really the only way for handling information was purely hierarchical at the time in computers. Maybe to some extent still is today. So hierarchical, this means you store files, and files exist in folders, right? So I can have, hey, this keeps happening, sorry. So I can have a folder like maybe I have a folder called home, and inside of that folder is a folder called John, and inside of that folder is this folder called desktop, and inside of that folder is this folder called SWE 432. Inside of that folder is a folder called lectures, and inside of that is a folder called 21.pdf. This is hierarchical in that this file is in this folder, is in this folder, is in this folder, is in this folder, is in this folder. And the way that I want to have to find this file is by first opening this folder, then this folder, 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 folder. And this can be cumbersome because maybe some files should get stored in multiple folders. If I were building this hierarchy, I might also have somewhere where I store some long-term files related to Mason. So I might have some folder called GMU, and then in that I might have some folder called teaching. And then in that it's maybe organized by year, and I've got like 2018. And then I've got the current semester, which is fall. And then inside of that, I've got SWE 432. And it might get even worse because maybe I have some collection where I organize lectures based on content and topic. It turns out between the different classes that I teach, sometimes there are lectures that overlap and have data that overlap. In particular, like this lecture right now, also has a lot of similar content that appears in a graduate course that Professor Latoza teaches. So maybe this is going to be /home/Latoza, and then he's also teaching some class at GMU, and it's teaching, but it's related instead to something that he taught in 2017 in spring. And the class wasn't 432, but I think maybe 621. And maybe it's not lecture 21, but maybe it's lecture 5.pdf. Maybe these files are related in some way, or maybe they're even the same file. And it's like weird because we're stuck storing things in this hierarchical system where we have a folder that's part of a folder, part of a folder, part of a folder. So the question is, can we do something else? Starting from the ground up. So the methodology was to interview 13 different Apple employees who were in different departments like human resources for about 30 to 60 minutes each. And from each employee, the researchers studied by observing and asking several questions, like when you receive information, how does it get there? Are you receiving things by mail? Are they coming by envelope? Are they being brought to you by an assistant who's already opened them and read them, perhaps? When you get information, what is it that you do when you get it? Do you read things immediately? Do you file things immediately? Do you let them accumulate on your desk? Do you have a method whereby you have things accumulate on your desk? Do you have an inbox and an outbox? Do you have priorities within those inboxes? Then after you get it, what do you do with it next? Does it transition between being stored in different physical places as you work through it? Where is it stored and how is it stored? Do you make copies of things? Do you organize things in a filing cabinet? If you organize things in a filing cabinet, how is that organized? Are things sorted alphabetically in that filing cabinet, or are they sorted by category and then by date, or are they sorted by date and then by category? And the last and maybe most important question that they asked, though, was most of the employees didn't have assistants, but they asked them to speculate, if you had an assistant, what would they do to make your life easier? How would they handle this information process to take some sort of the weight off of your shoulders? And the reason for asking a question like this is the researchers would like to envision that the computer interaction that they're building is going to be similar to saying that you have an assistant that's helping you, right? So a great way, without saying what should the computer do, is to say, well, you're not using a computer for this task already. You've got all of these like physical papers, and then you've got these filing cabinets, and you've got like folders, and you're taking those papers and you're putting them in these folders. Maybe that's a folder, binders. The paper goes in the folder goes in the filing cabinet. How do you do that? And if you had an assistant, how would they help? Would the assistant be able to automatically put things in folders, or automatically put folders in filing cabinets, or sort things or organize things before you get them? So the results of the study was that how did the users handle this information? Well, they used all different kinds of physical artifacts. They found that they used artifacts like folders to group related pieces of information together. And then from those folders, they would store those folders maybe in filing cabinets or in racks within those cabinets or out on desks. And they would sort and organize things into folders, into cabinets, and into racks in all different ways. Maybe they would use binders to group together related folders and related files. And they also found that users would use piles. Just on their desk, you would have different documents literally piled on top of each other. And for a lot of users, they found that there was maybe even some sort of method to the way that stuff was being otherwise seemingly randomly piled out. And the problem that they got back from a lot of users from doing this real-world filing of putting files in folders and putting those folders in filing cabinets was that, here's a sample quote from one of the users in their study, users just really had a hard time filing things because they have a tough time applying categories to stuff. If I have a file and this is my lecture 21 in this class, I need to think about where exactly is the most important place to file this. Do I file this under teaching for this class? Do I file this under teaching this topic of design thinking, because that might show up somewhere else? That's maybe an easier example, but if I have a financial report from this quarter, do I file that under financial reports, or do I have maybe some other file of recent things that are important for me to act on? And if it's related to specific projects, do I have files for those projects, or do I have files based on dates or category? And users found out that users related that they were getting frustrated with doing filing because they like that things get put away in the right place, but sometimes they can't figure out exactly where that right place is. So piles. The researchers found that most workers were keeping information that they needed, that they were actively working on, in specific working areas on their desks. So they would create different piles for each project and place their related documents within that working area at some distance that reflected how urgent that project was. So maybe the stuff that's right in front of us here is something that we're working on right now. Here's stuff that's important that I need to look at later this week, and I've got it there to remind me that it's something I need to work on. And it's kind of just sitting there loosely grouped by the fact that I need to work on it. And the researchers found that even though a desk like this might look like it's totally disordered, they end up being relatively sensible to the people who created them. Because of the way that this specific worker has decided to set things out on their desk is what works for them and what they've developed over a long period of time. So what's interesting about this approach of keeping lots of data that you're working on right now, like in the moment in these piles, is that it doesn't really require that same level of detailed categorization, right? If we compare piling stuff out on your desk to filing things accurately away in cabinets, if users reported that they were kind of apprehensive about filing things because they were worried maybe things won't go in the right spot, it's important to them that everything is in the right place, a pile is much more casual, right? It's easier to change which pile a document is in. You can just pick it up and throw it in another pile, much more so than it is to go through a cabinet and find something and reorder it. Yeah, so this was maybe kind of interesting to the researchers because all of the ways that we were storing data on our computers, again, were this file folder kind of metaphor, which didn't maybe then really support as well this grouping of active information that people are working on in some sort of short term, like days and weeks, that we want to keep this context for and are keeping on their desk in these kinds of organized piles. So the insight from these researchers from the study was that there are many different tasks that don't really rely on having some files organized in a hierarchy. So for a lot of things that you're doing on your computer, doesn't really matter that stuff is being filed away like in folders and cabinets. This work was not just a short footnote, not the first to suggest using piles as a design metaphor in computers. This had been described nearly 10 years earlier in 1983 by some folks at Xerox PARC. It turns out, if you're not familiar with this, like every way of interacting with a computer that you do today was first described at Xerox PARC in the early 80s, and then Xerox PARC imploded because they weren't able to commercialize anything. Oops. So the researchers were really interested, though, in studying how workers were using piles in their everyday work to then try and get from there to saying, what can we do as we're building interfaces for our computer? So they found from interviewing more and doing more observational studies about how workers were using these piles, they defined these 4 different interaction techniques of how workers were using the piles. So the first was edge browse. So that was, I've got a big stack of files sitting in a pile, and I can just look at the edge of a pile and see, like, here's a thick document, here's a thin document, here's a document in a green folder, here is a binder, which looks totally different. And use that as a cue just to, from looking quickly into the side of a pile, pick a file out. They found that another way would be maybe restacking to browse through a pile where you start at the top and you start flipping through it, removing things as you go down. They found that workers maybe would hinge a pile. That would be where they would take a pile and like fold it open as if it were a binder. So take somewhere in the middle, flip it open, and look at what's inside of it, and maybe flip through it. The last high-level interaction that they found, they categorized as spread out, where a pile gets like laid out on a big table so that you could see all of the items or many of them at once. So the other interesting thing that we got back from the study was looking to the answer to this question of if you didn't have assistant, what would they do? And users reported that what they were most interested in was having an assistant who would sort incoming data into categories. So I might be working on lots of different projects, and I'd like my assistant to bucket all of the papers that I'm getting into categories based on those projects maybe. So that then as this worker, I can look at all of the documents related to one project, all the documents related to another project, or use some kinds of rules like this. The assistant might filter incoming data to take things that are urgent and place them in one place, and take things that are not urgent at all and maybe put them in a different area. And based on this filtering and categorization, the assistants might literally be creating piles. So they're not putting things away in a filing cabinet, they're not putting things directly on my desk in a completely unordered way, but by some notion, they're creating these groupings in piles. And their workers reported that what was key was the assistant wasn't going to work completely on their own. The assistant was going to work in collaboration with the worker. So maybe the assistant is going to go into my office and put some piles on my desk or on my floor and label them with how it was that they were roughly categorized. And then the worker is going to look at it and say, no, this doesn't make sense how you organize this, or that's pretty good, okay, keep organizing things in that way. So the researchers then went on to create sketches of what a digital pile system might look like, which made it much easier then to start to evaluate the idea of piles in a system and discuss it more in a greater detail. So one example sketch for one kind of interaction is looking at how maybe you can pile things where either the end user is creating the piles or where the system is automatically creating the piles. And it was really important here that this kind of interaction conveyed that a pile was created by the user or that it was created by the system, because the researchers found that the workers were really interested in working in collaboration with this assistant. They wanted to know what was the work that the assistant did and what was the categorization that the user did themselves. So they came up with the idea of using this metaphor where the user-created pile is maybe messy. It has files interleaved and not stacked neatly, whereas you could tell quickly which pile was created by the system because it was stacked neatly. You could look at features like how you can add a file directly onto the pile, maybe a new file. Could start getting closer to storyboarding this out and show the multiple frames here of what would happen where a file gets dropped onto the pile, and as it's hovered there, the system has some sort of animation that shows visually directly that that file is being added on top of the pile. In fact, you can see there's some cues here that like this page looks just like this page. It's the same thing that's being added. You can envision then how you might have this collaboration between the system and the user for defining these new rules. So I can see here in this first frame that there are two system-created piles because they are nicely stacked neatly. And we're showing in the storyboard that a user is selecting an item from one pile. Here I clicked on, I guess, the top thing from the other pile. And now it shows up because I selected it. And then we drag and drop it onto the important pile. And because we're doing that, and I've got these two system-created piles, we're showing that the system is going to give this suggestion here of, do you want to just add this item from other to important, or do you want to change how we define this important category so that it happens automatically in the future? And then we show what the interaction might look like if we selected to update the pile script. Could look at They also then took all of the different kinds of browsing that would need to be done based on those interviews and built out these sketches to show what it would look like. So for instance, they had identified the spread out metaphor, where an entire pile would get literally spread out on the table, and discussed how you could do this by taking your mouse and dragging it across a pile, which would then result in seeing the pile literally spread out like this, so that you could get more of an overview from looking at the top pages of each page in the file. They also looked at, again, the rest of these interactions, like hinge, where you took a pile and you wanted to peek into the middle of it just by selecting some part of it. So this is browsing and maintaining structure. So the pile still stays in its current view, but then you get to peek inside of it and see what a document looks like, and maybe even pull it out. They consider different ways that you could, for instance, visualize an entire pile, all the contents in it, where maybe you're able to, in addition to being able to order this data and color this data in some way, you could pile data by content and have it ordered in some way, ordered and colored by date, but now we're pulling stuff out into the piles. You can tell, again, we have some piles that are system created, television architecture, and portable computer, where I guess some rules that we created, and other is everything else that doesn't fit in, and because it's ill-defined, they're showing that it has the leaves spread out like that. So after building the prototypes, after building these sketches, they then built prototypes and conducted studies where they had users actually work with the system and see what happened. We'll come back and talk about prototyping and user studies in the upcoming lectures. But even just from looking at these sketches, you can start to think about what maybe are good and bad things in this pile metaphor. And I'll cut to the chase here. You can think about this on your own. But most of the issues started arising with more complicated interactions with piles. So if a user were to say, select here, and then drag it here, does that mean that the user is pulling the top document off the pile? Or is that selecting the whole pile and taking the whole pile and moving it somewhere else? What is the distinction between selecting the pile and selecting a document? Maybe even worse, what happens if there's a folder that's placed on a pile, and then I drag a document on top of that pile? Am I putting the document in the folder or on the pile? Can I add groups of things to a pile at once? How do I name a pile? This is really just scratching the surface of this pile idea, and there's a lot to be figured out. What's the legacy of this then? So a patent for this idea of organizing data in piles was issued to Apple almost 10 years later in 2001. Not much happened with this idea of pile-based interaction until 2007, where macOS 10.5 introduced this view called cover flow. This is really the representation of that hinge view, where it's almost like I've got a pile of images here. The pile is automatically generated by the system. It's all images. This is this other way to find files, right? This is almost like the save search is kind of a pile, right? Doesn't matter what folder these images are in. It bypasses the folder thing. It gives us a stack of these images. And when we browse through it, we can pick a single one and then view closer at it here. This interaction, it's like there's a pile of images, right? And I'm holding it open to open it to the middle, and I can see what the next one is and what the previous one is, and I can kind of see the other pages and I can fan through it. This is pretty much the legacy of this hinge view. OS 10.5 also introduced the notion of stacks. Stacks, really similar to piles, right? Probably just what happened was some marketing person said, we should call it stacks, not piles. And some engineer said, why? The marketing person said, you can ask your kids, you'll get it one day. So notion of stacks, where you have some folders, maybe in the case of 10.5, it was just the downloads folder, where the design rationale as well, your downloads folder ends up having hundreds of files in it because stuff gets accumulated in there and there isn't much structure to it anyway. So maybe we can have some way where you can quickly just pull out the things that you care about, and maybe the things that you care about are the most recent things, so you can browse right into the downloads and start unfolding the top of it in a stack. This then continued even more. The most recent version of macOS 10, 10.14, just released this past fall, introduced the notion of desktop stacks. So everyone has really nasty desktops. This is a surprisingly not nasty version, screenshot of my own desktop. You can see there are files kind of all over, and this is obnoxious and not really browsable. So with desktop stacks, all of these files can get automatically organized into stacks on our desktop. Or maybe these files are stacked by kind. So all of the PDF documents go into one stack. All of the spreadsheets go into one stack. Something that you can tell is a little bit different, though, compared to the original design, is that this does not look well organized, right? I have this thing where you can kind of see documents poking out here. That's probably a design decision because they didn't want to have this be a 3D stack of files. And it needs to look 2D like this, but you need to still have some way to represent that there are multiple things here, so they do it like this. You can stack by kind. You can also stack by things like when they are last opened. You can tag files and then stack by tag. So I've got like my 432 tag here, and all those 432 files show up there. And you can take a stack and you can open it. So here I open the 432 stack, and you can see these two files here that were part of that stack get shown directly under it. Interesting sidebar here is one of the pain points that we had in the pile metaphor was what happens when you put a folder in a pile. And you can see in all of these different versions of the desktop stacking in macOS 10, folders cannot be part of stacks. You see I'm a folder showing up after everything else in all of the cases. Maybe one day that'll get figured out. But hopefully this example kind of helps you understand a little bit more how we can go through this iterative process, go through this iterative process from the start, where we'll start with some high-level problem, like how it is that we organize data that we're getting on a daily basis and how we browse through it. And then go from this high-level problem of organizing data to studying users, finding how it is that they're doing it, and trying to understand what the pain points are, the things that we can improve. Doing sketching, coming up with these new kinds of interactions, and then starting to validate them. So we'll pick things up on Monday back in person. Reminder to keep working on that homework 4. It's going to be due really soon. Happy hacking. Have a good weekend.